In this video, we're going to talk about what is a transformer and a rectifier. So here I'm showing a transformer right here. And it has an iron core, and we have voltage coming in, and it's 120 volt, and it's wrapped around a certain number of times and goes back to the source. And then we have voltage going out, and it's wrapped a certain number of times around the core. And we call the coming inside the primary and the going outside the secondary, okay? And so a transformer is a device that takes in voltage, and it can either raise it or lower the voltage going out, okay? And you can apply this formula where we have the number of turns on the primary side, that's how many times it's wrapped around, divided by the number of turns on the secondary side, is equal to the voltage of the primary. In this case it was 100, divided by the voltage of the secondary. And we can solve for what the voltage of the secondary is by just doing a little bit of algebra. And so if we fill in this, we have, in this hypothetical situation, I've put in 1,000 turns over here, and we have 2,000 turns around the iron core on the secondary side. And I told you that we have an input of 100 volts, so our output, if we just solve for V secondary, is going to be equal to 200 volts AC. So in this case, the transformer increased the voltage coming in from 100 to 200 volts. Okay, and then let's say you have a laptop here, and a laptop runs off of DC electricity. That's direct current that we talked about. Okay, so it runs off of DC, but our wall socket in our house provides AC, so it's 120 volts AC, okay? And so on your power cord, there's this like brick here, and it consists of a transformer and a rectifier. So what's happening is that the transformer part of it decreases the voltage down, and then the rectifier is a device to turn AC into DC, because your laptop and other electronics run off of DC current. And so what is a rectifier? A rectifier is a circuit that changes AC to DC. And so here I show AC signal again, as I've shown you before. That's what comes out of the wall socket here. And it goes from plus, minus, so it's alternating. And then we run it through a rectifier, and it basically changes it to all positive. It never goes negative again. And then we can run it through a capacitor to smooth out these bumps. And so the net effect is we have 120 volts AC going through a transformer, and then we have a transformer lowering the voltage to, say, 12 volts AC. Then we run it through a rectifier that changes it to DC at this point, and then we could have a capacitor to smooth the DC current. Okay. Let's see. This slide is optional, and I've marked it optional right here, is because it's not talked about in your merit badge pamphlet. Why does the USA use AC for electricity transmission? And it has some benefits. First, the generators that make electricity make AC. Okay, they don't make DC. Usual, except for like solar panels. Solar panels make DC current. It's easy to step up voltage by using a transformer. Okay, and so the transmission power lines may be in the 200,000 to 500,000 volts. Okay, and high voltage step implies low current, okay? And the reason is that transformers do not change power levels, only voltages and currents. So previously I told you that the power is equal to the current times the voltage, okay? And so in this situation right here, I'm saying if we had a power of 1 and we had 120 volts, that implies a current of 8.3 milliamps. But if we change the voltage to 500,000, but the transformer is not affecting the power, then the current's around 2 microamps, okay? So it's a lot less current. And I put this second formula here, which is just from Ohm's law, which I previously said is equal to the voltage is equal to the current times the resistance. And I already told you what the power was. So if you just substitute in this for V, then you could say that the power is I squared times R. And so now we have a much smaller I here. And so the power loss, we could say this is the power loss, is now going to be this tiny current times the resistance. So the transmission lines that you see, the overhead ones, they do have some finite resistance. It's low, but it's still there. So if they can make the current very tiny, then the power loss over a given length of transmission line will be less, okay? And then ultimately, before it hits your house, the voltage is stepped back down to like 120 volts. So why do we use it? Because most of the ways that we generate electricity are AC. It's easy to step up to high voltage, and then when we're transmitting the power out to different subdivisions in your town, we're getting very low loss because the current is very tiny.